so that's basically the whole creating nuclear fission. But I guess were there any like dangers in like creating it with like the radiation and stuff?
Oh yeah.
Okay.
Okay, so there are lots of issues there. Some of those. So first of all, I guess one person actually died at Los Alamos working on it. I forgot who it was. Otto Frisch actually came close to killing himself.
Didn't someone just sever, or not sever, but severely damage their hand and arm?
I'm not sure.
I remember seeing a photo of someone who nuclear radiation charred their hand.
Right, but I don't know whether that was at Los Alamos. One person died from acute radiation exposure. Otto Frisch came very close to killing himself during the so-called tickling the dragon experiments, where they, when uranium-235 came close, they built things which were just barely critical, and it was so close that when he leaned over the experiment, the neutrons bouncing off of his body and back into it were enough to put it from subcritical to critical. And he managed to knock the thing over without killing himself. But they were much more cavalier about radiation than we are now. That's one statement. The issue with risks, and certainly people recognize risks. So, for example, one of the reasons why they built the reactors to do the plutonium production in Hanford, Washington, rather than in Oak Ridge, which is where they did the uranium separation, was that there was a concern that if something went wrong with the reactors, it would contaminate the whole thing, and that would kill both parts of the project at once. So they actually did it so they were aware of risks. At the same time, to give you an example of how cavalier they could be, I told you that they built the first reactor under the squash court in Stagfield. Okay. So, who authorized that? Well, the Manhattan Project was working on it. The University of Chicago, quote, metallurgy lab was run by Compton, Arthur Holly Compton, who's in charge of the whole setup. Fermi's doing the thing. Now, you would think that if you were doing something with a reactor, with unknown technology, you would tell the president of the university, by the way, we might, and the mayor of the town, of Chicago, that, if things go wrong, maybe Chicago won't be inhabitable, right? They didn't. Compton, on his own, said, this is, if I were to tell the president of the university, Hutchins, that, we're dealing with this stuff, he's a lawyer, he'll have to say, don't do it. So, but this is too important, so let's just do it. And in fact, the methods they used to make sure nothing went out of control were kind of interesting. So, Compton was convinced things were okay because Fermi developed a system of control rods of cadmium, which basically eat neutrons and can therefore slow the reaction down. And that's the way you made the reaction to go on and off, was by pulling these things in and out. But what happens if something went sort of catastrophically wrong? You wanted to stop it right away. Well, they had two methods. They had these other rods, again, cadmium, that drop. So these ones you pull in and out from the side, that just drop in vertically and under the weight of gravity. So they just would fall in, and they were held up by an electromagnet. And the electromagnets were attached to neutron detectors. So if there was too much radiation, it should stop itself. Okay. And then, just in case, they had another set of those things attached to ropes. And they had some physicists carrying axes to chop the rope if things went out of control. Now, okay. Yeah, so they were taking precautions, but gee, if you really need a guy with an axe, is this the smartest, doing this in the middle of Chicago, the smartest place to do it?
The squash court.
Yeah. The squash court's actually kind of amusing. Apparently, Russian spies heard about this and sent the information back to Russia and got it wrong because the word squash could mean like a vegetable, and reported that this reactor was being built in a pumpkin field instead of a squash court. But anyway.
That's funny. So we're talking about all the money and effort
Mhm.
that like went into the whole Manhattan Project.
Yep.
And just like maybe in like your opinion or like with like some stuff backing it up, would you say like is it worth it? Like was it worth like the whole?
Well, okay, so just you have to figure out what. So it was about $2 billion.
Which is a
Which-
lot of money back.
Well, okay, so by today's standards is kind of peanuts. I mean, really, really peanuts. But you can do a little calculation. You can look up the cost of, the rate of inflation, and compare now to 1942 or whatever.
Mhm.
And if you convert, that $2 billion turns into about $23 billion,
Yeah.
which is still not a lot of money. Just to give you a sense of scale, it's about what Americans spend on video games in a year. Okay? I mean, it's real money, but it's not. Of course, the country was much poorer then, right? So maybe a better way would be as a fraction of the gross domestic product. And I don't remember the number offhand, but it's roughly, as a fraction of GDP, about equivalent to $100 billion today, which is, again, real money, but not an insane amount. Of course, at wartime, one of the things that's interesting is every dollar you spend on this apparently crazy project is a dollar that you're not spending on a battleship or a tank. Right? So that's the bigger question to me is not whether it was worth it. In retrospect, if you knew it was going to succeed and you had no moral issues whatsoever, then obviously it was worth it.
Yeah.
The cost of invading Japan would have been larger by orders of magnitude, right?
Yeah.
What I find remarkable is that you have a bunch of scientists talking about what must have seemed like science fiction at the time, and yet managed to get what was real money by that standards in a time when money was hard to get a hold of. And not just money, but resources. I mean, Leslie Groves had permission to get whatever he wanted. You want the highest quality carbon steel? No problem. Okay. He had to yell and jump up and down to get that, but, and that was, again, steel that wasn't going into battleships and the like. So, so there is something remarkable that happened, but obviously, from a military point of view, that was a good investment at the time. We can ask whether it was good for the world, but that's a separate question.
Yeah. Okay. So basically, like our whole like idea.